All right. So welcome everybody to Hoon Academy Lesson 3. So in this class, we're going to increase our understanding of Hoon's type system, and we'll learn how to make more sophisticated types called molds. Once we do that, we're going to learn how to do logical decision making in Hoon, which is an essential part of any programming language. This is an important lesson in which we'll start to write what looks like real complex Hoon code. Hassan says the recording sound was loud. Hopefully my voice and the other sound is all right. I'll let me know if there's any issues. All right. So in last class, we went over quite a bit how to use Hoon's type system for atoms or single values. I'm low on volume. Am I low on volume for anyone else or just Hassan? Wit says no. Might just be you then, somewhat, but it's fine. Let me check if I'm using the right mic. I am lowish, it's okay. Okay. I would keep going then. You guys might have to turn it up a little bit. All right. So, recall that Hoon's auras fit inside each other if they nest in a tree-like structure like this. For example, pat UX always fits under pat U, and everything fits under the pat aura. And we learn how to use the Ketheb rune as a fence to make sure that the result of a computation is a certain type. For example, here, we're doing add 1, 2, and using Ketheb, we're going to say, make sure the result of that is a pat UD. And it works, and we get a 3. Okay. In addition, we learned how to get the default value of an aura with ket_tar. So for example, to get the default value of a floating point, we do that. And we can also use the sugar syntax, which just looks like this. All right. So this is all great, but so far we've just been dealing with single values. So for general computing, we're going to need types for more complicated structures like tuples and lists and maps and so on and so forth. More elaborate data structures, right? Hoon covers more complex types with what's called a mold. To use an analogy with chemicals, so if atoms are like atoms, molds are like molecules, more complex structures that are built bit by bit out of atoms. So molecules can be simple like the water molecule or complex like a DNA molecule, right? And the same goes for molds. All right. So let's learn how to write some molds. When you're writing Hoon to create a mold, you change into a certain type of writing called structure mode, okay? So structure mode is when the Hoon parser is interpreting your code as a specification for a type rather than directly writing something that computes a value, okay? So let's look at an example to understand what this means. So here, we're saying tis faz word and the text hello, and then we're just going to return word, okay? And that returns hello, right? From last lesson, we should understand what's going on here. We're pinning this piece of data to this face, and then we're returning that face, right? We can also add a little bit of type information to this word, and this specifies that this thing must be of type pat_t, okay? So, and that gets the same result. The only difference is we add a little bit of information right here, all right? So it turns out this is actually a sugar syntax, and the sugar syntax for this following rune right here, okay? So buck tis. So, what does this rune do? Buck tis is going to take a face and a type And in structure mode, it's going to say this face has to be something of this type, okay? And importantly, now we've seen two different kinds of syntax where we say like A equals B, right? So we can do simply like word equals hello, or like something more complicated like this, right? Um, and in the last lesson, we actually learned that this is sugar syntax for the ket-tis rune. The ket-tis rune, which you learned last lesson. And this is in value mode. So we're talking about values. We're saying this face should refer to this thing, which is a value. All right. Alternatively, we can use the syntax A equals B in a different way, this way we just learned, which here we're doing word equals pat t, and that's in structure mode. That's saying this face has to have this type. Okay, so and that is going to be in structure mode, this buck tis. Okay, so it's important to note that these two syntaxes, even though they look kind of similar, they desugar to different things depending on whether you're in value mode, talking directly about values, or you're in structure mode, specifying a structure or a type structure for something. All right. So are there any questions about that? Okay. So let's go through an example of building an actual mold using structure mode. Okay. So what's a useful application we might have? We might want to make a simple bank app on Urbit, right? And we might say each account is represented by a PAP, and for each account, they have an associated amount of money, and we'll store that as a PAT-RS. And we'll want those two pieces of information to be linked together, right? So each PAP has a certain PAT-RS amount of money. So to do so, we are going to use a new rune called buck coal. Okay. So buck coal is a rune for specifying something in structure mode, creating a new type. It takes an indefinite number of children, so you can put as many things as you want in here, and you need to close it with this tis. All right. And it's going to create a new type, which is a cell of these many things that you're putting in, right? So if you give this buckhole 2 children, it's going to make a type that's a cell. If you give it 3 children, it's going to make a type that's a triple. 4 children, it's going to make a type that's a quadruple. Okay. So let's use this to make a new data type. All right. So here's our piece of code. All right. And let's try to understand what's going on here. Okay. So to parse this piece of Hoon code, we're going to start with this buck coal on the outside. All right. And then next we're going to see this buck tis. This has 2 children. And this is going to say, remember this buck tis takes a face and a type. All right. So this is going to say, in the first entry, we have something of type PAP, which is has a name ship. Then we see another buck tis, and that's going to tell us in the second entry, we have something that is of type PAT-RS, and we give it the name money. All right, and these two are the 2 children of this buck coal, and then we close it off with this tis. All right. So if we want to keep this in our dojo state, we can use this syntax right here. Okay. We're gonna give this mold a name bank account, and we're gonna keep it in our dojo with this tis bank account and then this mold definition here, right? So this is just a dojo specific syntax. It's gonna say let's store this so we can use it in our dojo session. All right. So let's press enter. Now let's check that our new mold has worked correctly. Okay. So Certainly the following piece of data should fit this mold, right? So we have a cell, and the first entry is Zod, and the second entry is dot 12345 6 dot 78, right? So this is certainly a PAT-P, and this is certainly a PAT-RS floating point. Now, how do we verify that this fits our mold? We can use the Ket-Hep rune, just like we used it with auras. We're going to say bank account. We're going to make this cell of data fit our bank account mold, right? So Ket-Hep bank account, which refers to this, and the cell of two pieces of data. And we press enter and we get the result. So this first entry saying ship equals Zod, and the second entry saying money equals dot 1234, etc. That's indicating that this worked correctly. All right. So it worked correctly by attaching the faces to each part of data. We can also use this syntax, which in this case is a sure syntax. So tick bank account, tick, and then cell. In this case, this is exactly the same as doing this when you're working with a mold. It's a little different than when you were working with an aura, because when you did this for an aura, this actually desugared to a double application of Ket-Hep. So just a slight difference there, okay? All right. So let's understand what happened up here a little bit more, okay? So let's substitute the full definition of bank account into our piece of code. All right, oops, make this a little bigger. So all we did here was, here we have this Ket-Hep bank account, Zod 12345 6.78. All we did was substitute the definition of bank account right here. This is just the definition, okay? And now this is the expanded version. Here we have the first entry, the mold, and the second entry, the value, okay? So when we ran this code, when we press enter here, oops. When we press enter here, first, the Hoon compiler is going to check the first position in this mold, okay? And it's going to say, this is supposed to be a PAT-P. Then it's going to look at the first position in this value and say, this is Zod. It infers that this is a PAT-P value, and it checks that PAT-P indeed nests into PAT-P, and we are good to go, okay? Next, it's going to look at the second position in the mold. The mold says this has to be PAT-RS. It's going to look at the second position in the cell, infers that this must be a PAT-RS. PAT-RS does nest into PAT-RS, and you're good to go. And having passed all the checks, it's going to return this cell with the faces attached, okay? So what happens when there's an example where this doesn't work? All right. So let's try the following. So here we have something very similar, except instead of Zod here, we replace Zod with the text hello. All right. So this should not work, right? Because bank account wants a PAT-P in the first entry, and this is a piece of text. All right. So what's going to happen is the mold is going to say, I want a PAT-P in this first entry. The Hoon compiler is going to read this first entry of the value, infer that this must be a PAT-T. PAT-T does not nest into PAT-P, and you're going to get a nest fail error. And that's exactly what happened. You have nest fail, need PAT-P, and have PAT-T. All right. Any questions on that? All right. So another example where this will not work. Oops. So Ket bank account, the cell of 1 and 2. Hoon compiler is going to read this 1, infer that it's a pat UD. Pat UD doesn't nest into pat P, and it's going to fail. And it's also going to read this 2, and pat UD doesn't nest into power S, and that's also going to make it fail, okay? So yeah, this also does not work. So this is kind of a long and complicated way. This right here is kind of long and complicated way to write a mold, all right? So in Hoon code in the wild, you probably see this in a much more readable way, right? And we can apply sugar syntax to simplify this writing. So first, you take this piece of code right here, this buck.tis, you sugar that into just ship equals pat p, and you sugar this into money equals power s, all right? Just like that. And then you can take this buck col on the outside, and instead of writing it with the room like this, you can just write it as a cell, like that. And this final version is much more simplified and easy to read, and that's probably how you'd encounter code like this out in the wild, all right? But we need to be a little careful. So there's an important point here, distinction between value mode and structure mode, all right? So suppose that we wanted to define a new mold with the tis-faz room, all right? So we wanted to do tis-faz bank account, and then let it be this same definition right here, right? Tis-faz bank account, the mold definition, and then ket bank account, Zod, and the number, all right? So that's going to work. But suppose we want to sugar this right here into something more readable. Usually this tis-faz room, it usually expects a value here, right? You might say equals bank account Zod 123, right? You usually use this and you put a value here, not a type definition. So if you want to sugar this, you need to use a slightly different syntax that has this comma in front. And that's just to make the compiler know that you are referring to something in structure mode, okay? Because if you just did a cell of 2 things, that would be like a value, all right? So we use this sugar syntax like this. And the rest of the code is the same, and it works, okay? So again, the lesson is that because this tis-faz usually expects a value here, we put this comma to make it kick into structure mode, okay? That's in contrast to this ket. In the definition of ket, it expects a structure mode. It expects a type definition for its first argument, so you don't need to do that extra comma, all right? So that's a little difference in the sugar syntax right there. Are there any questions on that?
Is that a consistent thing? Placing the comma in that position will always tell the compiler now interpret the following in structure mode?
Yeah, I think this is consistent across a few different syntax forms, but yeah. It's in particular, this is a sugar syntax. So like if you put a comma in front of a room, that wouldn't parse, but this comma in front of these brackets, because brackets can be ambiguous, right? Okay, so one more place that structure mode can show up is inside the first argument to a tis-faz. So here we're doing tis-faz, and we could actually do something like this: ship equals pat p, money equals power s. As a cell of 2 things, we're going to say this cell of 2 faces is this cell of 2 values, all right? And that is going to work. So this desugars as follows. Desugars like this. Okay. All right. So let's move on. I'm going to show you something interesting. So what happens if I call my mold like this? So what am I doing here? Send have bank account. Hello. Dot 12345 dot 78. All right. So do we recall what this send have rune does? Can anybody tell me?
Calls a gate.
Yep, it calls a gate. So maybe it's a bit of a mystery why it's here, right? But let's press enter and see what happens. And it works, and it actually gives us ship equals daspel bigreg famtol, and money equals 12345 6.78. All right. So, but if you recall, we just tried the same exact thing, but with a ket hep here instead of a send hep, and this failed. Okay, this gave us a type check failure. So what's going on here? So it turns out that any mold is also a gate and can be called as one, and that gives us slightly different behavior than when we cast it with kethep. All right. Recall that when we use kethep, we're doing element-wise checking to make sure each part of the value fits each part of the mold. However, when we call it with senhep, we're treating the input cell as a raw knockdown. We're just looking at the underlying numbers under this data. All right, we throw away all of the type meta information. We're just treating this as a number. We're just treating this as a number. And then we're gonna force those atoms to fit the auras in the mold. Okay. So we can even just do this on the cell of 1 and 2. Oops. It with a senhep. With a senhep to call this as a gate, this works. So we made the cell of 1 and 2 fit our bank account mold, and 1 is the underlying number of the galaxy neck, and 2 is the underlying number of the floating point, 0.3 e negative 45. So it's a really, really small floating point. Okay. And we can even do this in sugar syntax that will look like this. Same thing, okay? So yeah, these two usages of molds are respectively called casting and molding, okay? So the differences between them are explained here. And kind of the most interesting thing, I think, is that casting with this kethep is checked at compile time, which means it's checked when the code is built, not when it's run. And it's going to catch any type errors that that are in your code so that it doesn't get out to the code when it's actually in production, right? Instead, the senhep is different because it happens at runtime when the code is run by the user, and it can possibly cause runtime errors. So for example, if I tried to call this bank account as a gate on the cell of 1, 2, 3, recall that bank account, we specified that's a cell of 2 things, right? So we're trying to make a cell of 2 things fit a cell of 3 things here. And we're going to get this dojo Hoon expression failed. That is a runtime error, okay? So in general, this step is safer. It's not going to make your users possibly have errors, but this molding is more flexible in that it'll let you use it with more things. It'll coerce this data to fit this mold. Okay. Any questions on that? So if there's no questions, then we should move on. There is one more rune that we should learn for making molds, all right? And that is the Buckwheat room. And suppose for whatever reason you want to make a type that's either a text or a floating point number or a date, okay? It can be one of three things. That's what's called a type union, and you make that with the Buckwheat room, okay? So let's try an example. We can pin this to our dojo. This tis new type, Buckwheat, pat T, pat RS, pat DA. Just like but coal, this takes indefinitely many children, so you have to close it with this tis, okay? All right. So now let's check that our new type works. So if we give it a date, cat have new type, this date, it will pass. And if we give it a pat UD number, it's going to fail because we have a pat UD and we need a pat DA, pat RS, or pat T, just as we specified, all right? And it'll let pat T and pat RS pass as well. But the quirk of the type system is that it's going to interpret this underlying atom as the last thing in the type union. So it's interpreting hello as a pat DA here. That's why it looks kind of weird. Same thing with the pat RS floating point, all right? So in practice, these type unions aren't used too much with auras. They're actually used mostly with the pat TAS constants that we learned in last lesson, the pat TAS term constants, all right? So if you'll recall, a term is something that looks like sen ABC dash 123. It's both a value and it's also a unique type in and of itself, okay? So let's try an example of using these terms with this Buckwheat room. Here, we are going to pin to the dojo a new type called reptile. And we're going to say reptile can be either a sen snake, sen lizard, or sen crocodile. And each of these are pat TAS terms, okay? Press enter. And we can also write this in the sugar syntax, okay? That's another way that we can write it that's a little neater. Equals reptile, this what, and then parentheses, sen snake, sen lizard, sen crocodile, okay? So let's show that this type works. Let's cast sen snake to a reptile, and it works, all right? So sen snake passes this type. We can also do this in sugar syntax. Tick reptile tick, sen snake. That also works. And we can check that something else like sen elephant, which is not a reptile, that is going to give us a type failure because we have sen elephant and we need either a sen crocodile, sen lizard, or a sen snake. All right. We can also use this as a gate too. All right, we can use our custom type as a gate. So we can do sen hep reptile on this really big number. And this really big number is actually the atom underneath the text of lizard, okay? So sen hep reptile on this big number gives us sen lizard. And if you call it on a different number that doesn't parse to one of these three texts, then you'll get a runtime error, okay? So any questions on type unions? All right, so let's move on. So let's imagine for a moment that you are running a reptile care facility and you need to keep track of how much you are feeding your reptiles each week. And suppose that you are keeping track of these in an Urbit app. All right. So you can use the runes that we just learned to create a data structure that will keep track of this data for you. Let's learn how to do so. All right. So in case you haven't, let's pin this reptile definition to our dojo. And then let's make a new type definition. And we're going to call it reptile tracker. And reptile tracker is a buckhole whose, so this, remember, this is a cell type. We're making a type that's a cell of two things. And we're going to say this first entry is something of type reptile, and we're going to call it, we're going to give the face species, okay? So species equals reptile is the first thing in the type, in the cell type. And the second thing in the cell is going to be meals, which is a pat UD, okay? So we're making a type. First thing in the type is a species of reptile. Second thing in the type is a number indicating the number of meals it's had, okay? So now that we've made this reptile tracker type, we can use it. Let's use it to cast the cell of send crocodile M3 to this type. And we get species equals send crocodile, meals equals 3, right? And here's the same thing in sugar syntax. We can also call it as a gate with this send hep on these numbers, which this is the number underlying lizard, and this is just the number 4. Okay. So this is a pretty straightforward and simple example of combining a type union. So the type union was the reptile, which is snake or lizard or crocodile, and a cell type. So we have a cell of a reptile and a meals number. Okay. So it's pretty simple, but you can combine these with as much complexity as you want. And with these two runes together, buckhole and buckwhat, you have enough power to make any reasonably complex mold, really, that you need for any reasonable data structure. All right. So like with atoms, we learned that we can get a default value for a mold, and you can do the same thing with we learned that we can get the default value for an atom, and we can do the same thing with a mold. Okay. So recall the bank account type we made earlier. Remember, we learned this ket tar rune, which gets the default value. All right, so we can get the default value for a bank account type. And that's just going to get the default value for a pat p and the default value for a pat rs and put those in a cell. Okay, so that's why we get Zod and money equals 0. And the sugar syntax would just look like this on bank account. Right. For a type union, if you use a buckwhat, it gets to the bunt of the last type in the type union. All right. So remember this new type that we made. If you do a tar new type, it's going to get the bunt of the pat DA. It's going to get the default value of a pat DA and give that back to you. And same thing for type union of terms. If you get the default value of reptile, it's going to give you send crocodile, which was the last thing in that type union. All right. And we can even do that for our reptile tracker type. So just to show you that you can get a default value for all these custom types that we just made. Okay. Any questions on that? All right. So Steve Massey says, can you redefine the default value? And the answer to that is yes. There's another rune that you can use to you can create a type, and you can say, I want this to be a pat UD, but I want the default value to be 5 for whatever reason. That's not covered in today's lesson. I'd have to jog my memory a little bit to recall what rune that is, but yes, you can definitely make a type with a different default value if you want. All right. So that's bringing us to the end of the section on molds, okay? So if there are any other questions on molds, please speak up. Otherwise, we shall be moving on to the next section on decision making. All right. So let's move on to decision making. In programming computers, making decisions based on whether some condition is fulfilled is a very fundamental and important part of programming, right? So if this, then do that, else do this, right? Hoon has a family of runes for doing so, and that is the what family of runes. So all these runes that start with this what, this question mark character, are about making decisions, okay? They're pretty straightforward to use and understand. Let's go through these new runes, all right? So the first rune that we're going to learn, and really the most fundamental rune here, because all these other runes can pretty much reduce to this one, is this what cult rune, okay? So how does this one work? Takes 3 children. The first is a piece of Hoon that either results in a yes or a no, okay? If this is a yes, then you're going to evaluate child 2. And if it's a no, then you should evaluate child 3, okay? So the simplest possible usage of this rune would look something like this, right? So what call send out y 1 2. What's going to happen? It returns a 1 because this is a send out y, okay? And if we go back and we change this to send.n, then it's going to return the 2, okay? So when it's a send.y, we take this branch, and if it's send.n, we take this branch, okay? So that's pretty straightforward. If we want to use this in a more sophisticated way, we have to learn a few more functionalities. So let's learn some arithmetic comparison operators in Hoon, okay? So basically, these are some standard library gates that let us compare the sizes of 2 numbers. Is x greater than y? Is x less than y? And so on and so forth. And they pretty much work how you'd expect. So here, send less GTH 1 2 is 1 greater than 2. No. Send less GTH 2 1 is 2 greater than 1. Yes. Send less GTH 10 10 is 10 greater than 10. No. Send less LTE 1 2 is 1 less than or equal to 2. Yes. Send less LTE 2 1 is 2 less than or equal to y, or 1, sorry. No. Okay. This gate disregards type information, so you can actually use things that aren't numbers like Zod and Wes. So is Zod LTE Wes? Yes, because underneath Zod is 0, underneath Wes is 3. Okay, and 0 is less than or equal to 3. Any questions on these? All right. So we should also recall the .tis rune that we learned before, which tests if 2 nouns are equal, right? So this .tis takes 2 children, runs them both, and returns if they're equal or not, okay? So it also has a sugar syntax, which looks like this. So this tis, so is 1 equal to 2? No. Is 2 equal to 2? Yes. Okay. This also ignores the type information and just tests for equality of the underlying knock now. Okay. So is was equal to 3? Yes, it is. Here's the expanded version. All right. And you can even use this to test for equality of nouns. So is a cell of 1 and 2 equal to the cell of 1 and 2? Yes, it is. Okay. Now, since all these GTH, LTE, whatever, and also this .tis rune, they all return a send.y or a send.n, we can plug them into our what code rune to make decisions, okay? So let's see some examples of that. Here, we're going to pin x to the number 3. We're going to say what call. We're going to call GTH on x and 2, okay? So this is going to return a yes if x is bigger than 2 and a no otherwise, okay? And if this returns a yes, we should take this first branch, which returns a text saying x was greater than 2. And if this returns a no, we should take this second branch, which returns a text saying x was not greater than 2, okay? So press enter and we get the text x was greater than 2 as we expected, all right? And if we change this number to 1 and put the same code in, we'll get this. This will give you no, and we'll take this branch of the code, returning the text x was not greater than 2, okay? And we can make this a little more readable by using sugar syntax, okay? So here we just simplified this send less into just this parentheses, the sugar syntax. And that makes this a little more readable, right? All right, so any questions on that? And of course, you can, instead of directly just returning a piece of text, you can put further computation in each of these branches of the what call, okay? So here, we're pinning x to 1. We're saying if x is greater than 2, return the result of multiplying x by 5. Otherwise, return the result of adding x to 10, okay? So x was 1, 1 is not greater than 2. We're taking this branch, returning 1 plus 10, which is 11, all right? Any questions? Steve says, are there versions of his, let, etc. that check the types of the arguments? Yes. So later in the lesson, we're going to learn about how to make decisions based on the types of pieces of Hoon code. All right. So, in computer science, doing Boolean operators are something very fundamental, like not and an or. Maybe you've heard of these. You'd expect these to be present in any programming language, and Hoon has these as well. Okay. So the rune for not is this WhatsApp. It takes one child, which is some Hoon that evaluates to send.y or send.n, and it just reverses that. Okay. So if you do a WhatsApp of a send.y, it's going to give you send.n. If you do a WhatsApp of a send.n, it's going to give you send.y. And the sugar syntax for it looks like this. You just put this zap, this exclamation mark in front of the Hoon, and that does the same thing, okay? So here's another example. So GTH23, this should return no, right? And this WhatsApp reverses it, so we're going to get a yes. And we can just put this zap in the front, and I'll do the same thing. All right. So the rune for logical and is what, Pan? Okay. So recall that logical and is going to take a bunch of yeses or nos, and it's going to return a yes if and only if all those yeses, all those choices are yes, okay? If there's a single no, then it's going to return a no, okay? So, for example, if we want to use this what Pam, send out y, send out y, send out n, send out y. This takes indefinitely many children, so we have to close it with this tis, okay? And this is going to give us a no because there was a no in here. We change this to a yes, then we're going to get a yes, okay? And the sugar syntax of this rune looks, you just put this ampersand in front of the parentheses, just like that, okay? With a more complicated logical expression, it will look something like this, okay? So GTH21, yes, 2 is bigger than 1. GTH32, yes, 3 is bigger than 2. GTH43, yes, 4 is bigger than 3. But this is reversing it, so this is going to give us a no here. And that's going to make this whole thing no. Steve says, does what Pam stop evaluating on the first send out n? That's a good question. I don't recall exactly how that parsing works. Yeah. I can try and get an answer to you after if you want. All right. So what Pam, logical and, returns yes if and only if they're all yeses, okay? The next rune we should learn is for a logical or, okay? And logical or says, sorry, I gotta sneeze. So logical or says, return me a yes if any of these inputs you give me is a yes. Otherwise, return a no, okay? So it's only gonna give you a no if all of them are no's. So let's see an example of this in action, okay? So what bar, let's give this all no's, okay? So it takes indefinitely many children, so you got to close it with this tis. And then since we gave it all no's, it's going to return a no, okay? And we change a single one of these to a yes, then we're going to get a yes, okay? And the sugar syntax for it looks like this, okay? So we're going to put this bar in front of these parentheses, and then all the arguments inside, okay? And that's going to give us the same thing. And you can use this with more complicated expressions inside. So is 1 greater than 2? No. Is 2 greater than 3? No. Is 4 greater than 3? Yes. So this is going to give us no, no, yes inside this logical or, which means we're going to get a yes, okay? All right. So that concludes the section on these Boolean operators. Are there any questions on those? All right. So if there's no questions, we shall be moving on. So alluding to a question that Steve asked earlier, we can actually make decisions based on information that the type system knows. So there's a couple examples of these, and the first one we're going to learn is this rune what sig, okay? So this rune what sig is going to do a branching based on whether this first child reduces to null, okay? So if this reduces to null, then we're going to do child 2. Otherwise, we're going to do child 3, okay? However, let's take a look at this code right here, okay? And so we're going to pin A to sig to the null value, right? And then we're going to do what sig A, then the text it was null, and then the text it was not null, okay? So from what we just learned, this should be like a really straightforward usage of this rune, right? A has this type, and it should take this branch, right? But actually, if we press enter, we get an error. It says mint vein, dojo Hoon expression failed. So what's going on? So this character sig by itself is actually its own special type, and because of this, when you do this tisfaz a sig, the Hoon compiler knows that the type of A is just sig. And because it knows that you're never going to take this branch of the code because A has to be this type. So it knows that it's not going to be not a sig, okay? And this mint vein error occurs whenever you have a branching conditional and the Hoon compiler knows that a certain branch of the conditional cannot be taken, okay? So how do we fix this? Let's confuse the compiler by casting this sig to a patUD. And then if we do the same thing, it's going to work. By casting this sig to patUD, it's going to take this branch. It was null. And we can even do this with just the numbers, right? We can just set A to number 0. It was null. We set A to 1. You get it was not null. Okay. So this is a little bit of a tricky thing that can catch people up, but just remember that mint vein error means that there's a branch that the compiler knows that you can't take, okay? Any questions on that? All right. So there's much more powerful tools than this one to branch on information about types, okay? Let's learn them. So using the type unions that we learned earlier, remember we made this type union like reptile is a sen snake, a sen lizard, or a sen crocodile, right? We can use those kinds of things to do these switch statements, to switch cases based on what type something is, okay? So our first example is going to use this rune whathep, okay? So whathep takes a bunch of children. It looks like this. The first child is going to be the argument, okay? The thing we're switching on. Then it takes a bunch of pairs, and it's going to say, if this thing is this type, then do this. If it's this type, then do this. If it's this type, then do this, okay? So on and so forth. And there's indefinitely many, so it's going to be closed with this tis at the bottom, okay? So to make this clear, let's see an example of this rune in action. So let's take a look at this piece of code right here, okay? So what's going on in this piece of code? Let's read it line by line, okay? So we're doing tisfaz reptile, And then this buck what, remember this buck what makes a type union that can be this or that, okay? And then we're saying this can be either a sun snake, a sun lizard, or a sun crocodile. And we're going to close this buck what with this tis tis, okay? So this is what we did before. We're making a new type called reptile, which can be one of these three things, okay? Next line. We're going to do tis-faz. We're saying an instance, we're going to make an instance of this reptile type with the face R, okay? So we're going to say R equals reptile. That means like we're declaring something called R, and it's going to be of type reptile. And we're going to give it the value / type lizard, okay? So we're saying R has the value and the type lizard, and it also is of the type reptile, okay? Next, we're going to have this switch statement, this what have, saying we're going to do conditional logic based on what R is, okay? Then we're saying if R is send snake, return the text, I'm a snake. If R has type send lizard, return the text, I'm a lizard. And so on for crocodile, all right? So let's run this piece of code. I'll drop it in the chat for you guys. So since R has value and type send lizard, this is going to predictably return the text, I'm a lizard, okay? And if we change what R is, if we change R to send snake, then predictably we are going to get a different result out of this switch statement. We're going to get text, I'm a snake, okay? So what happens if we add an extra branch to this switch statement? If we, in this what have, we add another pair for a send turtle and say we want to return the text, I'm a turtle. We're going to get a mint vein error. And that's because, as before, we learned that if there's a branch in the conditional that we can't take, that the compiler knows we can't take, then we're going to get this mint vein, right? And why does the compiler know we can't get a send turtle? Because up here, R is of type reptile, and reptile can only be send snake, send lizard, and send crocodile, okay? So it can only be one of these three things. The compiler knows that, and the compiler knows there's no send turtle in this type union, okay? That's why we get an error. Any questions on that? All right, so another rune, very similar to this what have rune that we just learned, but just a little different, okay? Just a small difference. The only difference is that it has this extra thing which lets you define a default behavior, okay? So you're going to give it an argument and you're going to say, if this, then do this. If this, then do this. But if none of these fit, then you get an extra default case to default to, okay? So let's see an example of this what less rune in action, okay? So here, in this piece of code, this is very similar to before. We're going to define a new type animal, which can be either send bird, send bat, send cow, send sheep, or send rabbit, okay? We're going to define a value, which is, we're going to call it A. It has to be type animal, and we're going to say it's a send cow, okay? We're going to do a switch statement on A. If nothing down here matches, return the text, I cannot fly. If A is send bird, return I can fly. And if A is send bat, return I can fly too. Okay. So let's run this code. And since A, we gave it send cow, it's going to return the text, I cannot fly. All right. And if we change it to send bird. It's going to return the text. I can fly. Okay. All right. So coming up on the end of the lesson, only a few more things we should cover. There's one more neat stylistic trick. And that's this this syntax right here. Okay. So here we define this type animal, this type union animal as before. And here we're going to do tis fas, this tis animal. So what does this mean? If we want to save some brain power, some namespace, we can just say tis animal, and this is going to make an instance of type animal, and it's also going to have the face animal. Okay, so that means if we have this piece of code right here, define this type animal, tis fas, tis animal, cow, and then we return animal, it's actually going to refer to this right here and get this instance of animal with this value cow. Okay. And that's going to be a different thing than returning this mold, okay, which is going to print a very long, big thing to the dojo. We'll figure out later why that returns a huge thing. Okay. All right. So for the last point of the lesson, we should talk a little bit about code style, writing proper styled code in Hoon. Okay. So with this lesson, we're finally learning how to write a bigger and more complex piece of code. So we should probably learn how to write it in a neatly and nicely organized way. Okay. So for technically correct Hoon, we only need to differentiate between a single space and two or more spaces. So if you want to do like this, what call send out y 1 2, right? So what call is saying this is the send out y, return this, otherwise return this. This gives us a 1. We could also wrote it all on different lines like this because pressing enter is the same thing as giving it two or more spaces, okay? And we can even do something like ugly and weird like this. Okay, so those are all syntactically valid equivalent pieces of Hoon code. But some of these look a little better than others, right? So for every rune, there's a standard way of formatting the spacing and indentation. So for example, if we go to the doc site, and if we look at the what call rune, it says we should format it like this. Okay, so we should probably do something like this. Oops. Just like that, okay? And this is a very neat way to represent this branching, and you can kind of easily see where the different parts are, okay? For our switch statements, like with the rune what hep, you could have written the whole thing on one line. Like, here's our reptile switch statements, all on one line, like that. And that's kind of ugly, right? It's difficult to read. It's hard to tell which parts go with which. And the docs say you should write it like this, or you should write it like this. Okay, these two tall styles. So here, let's fix our code and put it back in the proper form with these pairs all on different lines. And that's much easier to read. You can tell this case corresponds to this result, right? All right, so for this homework, you're still going to be working in the dojo. You're not going to be saving code to your fake ship just yet. But a useful tip at this point, since we're going to be writing bigger pieces of code, is you can start drafting things in like just a notepad or your text editor, and then you can copy paste it into the dojo. That way you don't have to like write something big like this and then like be pressing enter and then like trying to fix it. Yeah, just write something somewhere else and then paste it into the dojo. All right. Okay, so that brings us to the end of the lesson on moles and decision making. So that was a big lesson, and we're really starting to get a handle on how Hoon is structured and makes decisions. Okay. Next lesson, we'll be learning about how to represent two important data types, which are list and text. Okay, that'll be a bit of a lighter lesson. All right, so that brings us to the end. I will stop the screen share and the recording.